We're going to draw some box plots here, and we're going to refer back to some previous data we did. If you look back on page 22, you'll find some data which we calculated for the tree girth diameter. And for this data, there was a stem and leaf plot drawn there, and we got a minimum of 81 centimetres was the minimum tree girth, lower quartile 91, median of 95, upper quartile 99.5, and a maximum of 104 centimetres. We've got to put this on a box plot. Always difficult to work out a scale here. I don't think it'll fit in if you do one square each, so I'm just going to put a line across here. To draw a scale, and I'm going to put 80 here and go up in twos. So 82, 4, 6, 8, 90. 2, 4, 6, 8, 100. 2, 4, 6, 8, 110. Okay, now I only have to fit between 81 and 105. Now what we do is we start with a line that goes from the smallest score to the biggest score. I'll do mine down here. I'm going to just work in pencil to the for the start, because there's bits that I want to rub out of this. So I'll start from 81 and go up to 104 is the maximum. So I'll draw a line between those two. And then I've got a box in the middle of the box plot which goes between the lower quartile and upper quartile. Now the lower quartile is 91, so that would be there, and up to 99.5, nearly right on 100 there. So I want to draw a box around that amount, so I'll go there's my box. And then we put the median inside the box. The median was at 95. 90, 2495 is here. So I'll just put a median in there. So that box goes from the lower quartile to the upper quartile with the median marked. And the other two things, sometimes got a box and whisker diagram. Mark in these are called the whiskers. From the minimum score to the maximum score, and you usually put a little endpoint indicator there. There's no fill inside the box, so you can rub the centre of your box out if you wish. Rub that centre line out. That's a box plot. Now, it also says, what does the shape of the box plot indicate about the spread of the data? This data tends to be spread to this side. You can see, and sort of clustered around this side. I think you could see if we once did I think we did a graph of this, and this is the graph here that we did of that data. I wonder if you can see it there. Okay, here's the graph of the data here, and I think you can see how the graph is skewed to one side. This data is actually skewed left. You say the tail goes out to the left, and we've got this tail going out to the left. We're going to do another question now, so I'll just pause for a minute and set it up. Going to do another box plot here, and this time there's it seems quite obvious here there's an extreme value, an outlier, and we're going to show that on our box plot. But first of all, we need to know these key figures. It's sometimes called a 5-figure summary: the minimum, lower quartile, median, upper quartile, and maximum. Now we can probably work this out without our calculator pretty easy. There's 26 pieces of data here, so that would mean the median would be the 26 plus 1 over 2. The 13.5th score 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means the median would fit in between right here. In between 57 and 58 is 57.5. That's our median. The lower quartile now, I guess that means there's 13 pieces of data there. So the lower quartile is the median of the bottom half. With 13 pieces of data, 13 plus 1 over 2 is the 7th piece of data. 1, 2, 3, 4, 5, 6, 7. That will be the lower quartile. That's 51. And the upper quartile is the 7th piece of data in the upper half. 1, 2, 3, 4, 5, 6, 7. So it makes it 61. Minimum, maximum, of course, 43 and 88. Okay. Data shows the times taken for factory workers to assemble an electronic component. So I suppose these are measured in seconds. We're going to turn over and do a box plot. Before we do that box plot, we're just asked to find the interquartile range and confirm that we've got an extreme value in the set. So the interquartile range is the difference between the upper quartile minus the lower quartile. For the quartiles, you can use the symbols Q1 and Q3. You can also use UQ and LQ. Both are okay. Interquartile range of 10. Now, to identify an extreme value, if there's a value there that is, obviously looks like it could be this one, if that's more than 1.5 times the interquartile range above the upper quartile, then it's an extreme value. So let's have a look at this. The upper quartile, Q3 plus 1.5 times the interquartile range. Well, that will equal Q3 is 61 plus 1.5 times 10. 1.5 times 10 is 15. 15 and 61 are 76. Now, this score of 88 is well outside that range, so it's definitely an extreme value. So we just have to say 88 is more than 1.5 times the interquartile range above the upper quartile. So it is an extreme value. Okay, how do we show that on a box plot? Well, first of all, we want to work out our scale. We've got to go from 43 to 88. I think we're going to have to go up in twos here again. So let's say if we put a line across here for a scale, and hope we can fit it in twos. Let's see. If we start here at 40, 1, 2, 3, 4, 50, 60, yeah, we'll fit it. 1, 2, 3, 4, 50. Okay, so the box plot. Now normally this is how we do it. We'd normally start at our minimum score is 43, so we're going up in twos, remember, so that must be 43. And our upper score is 88. I'll just put it there for the moment. Go up to 88. And draw in pencil. I'll start and draw a line between them. And we're going to put a box in the middle, and the box goes between 51 and 61. With a median of 57, 56, 58, 57.5, so it's just there. Now I'll go over part of this in pen now that I've got it organised. Now for a normal box plot I would start here and finish up here, but I want to indicate that there's an extreme value. One value there that's not really indicative of the way the rest of the data is behaving. So what you usually do in circumstances like this is you put a cross just to indicate your extreme value. So I'm going to put a cross there, and now the next piece of data becomes my maximum. Now the next piece of data, looking back to my original figures, was 66. So that would be just here. So you can clearly see that that one figure is an extreme value. So there's one worker there that is very slow. And that's pretty much it. I'll just rub out some of those pencil lines. And that's pretty much what we're trying to achieve.